The Indian Space Research Organisation, ISRO, has crashed a satellite in Pacific Ocean, marking the end of the mission on Tuesday, March 7, 2023. Re-entry of Megha Tropique-1 MT1 satellite has been successful, after serving for over a decade. But why satellite is destroyed? Let's find out. MT1 was launched into low Earth orbit, LEO, on October 12, 2011, as a joint mission developed by ISRO and the French Space Agency, CNES, for tropical weather and climate studies. The mission was initially planned to operate for 3 years, but it was extended later as it continued to deliver key data about the climate for a decade. Now, what to do when life of a satellite is over? Depending on height of the satellite, there may be two options. First option is for satellites far away, for example GEO of around 36,000 kilometers from Earth. They will be sent to graveyard orbit. Graveyard orbit is located at a higher altitude than the operational orbit and is designed to minimize the chances of debris re-entering Earth's atmosphere. Objects in the graveyard orbit will remain there indefinitely, as there is no practical way to remove them. Second option is for satellites near to Earth, e.g. LEO. They will be slowed down by using leftover fuel and will fall down to burn due to atmospheric drag or friction. Now, why ISRO is crashing MT1 into Pacific Ocean? Sometimes whole satellite may not burn and some pieces may hit the ground. That's why controlled re-entry is necessary to crash the satellite in inhabited area like Pacific Ocean. Next you can ask, why to destroy a working satellite? ISRO is crashing the satellite as part of its commitment to the United Nations Interagency Space Debris Coordination Committee, UNIADC. The satellite could be left for good in its orbit as it continued to decay. However, in that case, the orbital lifetime of MT1, weighing about 1,000 kilograms, would have been more than 100 years in its 20-deg inclined operational orbit of 867 kilometers altitude. The MT1 spacecraft still had about 125 kilograms of onboard fuel that could pose risks for accidental breakup. This accidental breakup may pose a serious problem of increasing space debris in large count. Leftover fuel was estimated to be sufficient to achieve a fully controlled atmospheric re-entry. Controlled re-entries involve deorbiting to very low altitudes to ensure impact occurs within a targeted safe zone. For MT1 satellite being in LEO with around 125 kilograms leftover fuel was having only option of controlled re-entry. That's why ISRO has done this experiment. Congratulations Team ISRO, for successfully conducting the re-entry experiment. Any questions? Please ask in comment box.